Hello everyone, welcome to episode 9. In this episode we're going to work on jumping for our character. And this is very much a Super Mario style jump where you press down quickly and you jump like 1.5 tiles about, or if you hold it down you jump up about 3 tiles. So we're going to work on getting this jump into place. I'm going to show you the details of the jump right now. So like I said, quick jump, 1.5 tiles. Long jump, it's hard to measure here, but I measured it in another place where it's a little bit over 3 tiles. We'll get to measuring later in another episode probably, once we have tiles drawn in our map. But yeah, so the other thing is, when you're walking, you walk and you stop. But if you're jumping, if you let go of the arrow key, the right arrow key while you're jumping, you still go at the same velocity, so you don't slow down anymore. And that goes for both ways. One more thing, you can jump, and as long as you're still going up, you can jump again. Not really jump again, but you can just kind of continue your jump. So you can press Z twice to jump and then continue your jump. But it doesn't jump as high as when you just hold it down.
So let's talk about the problem and our solution. So we need quote to jump when the Z key is pressed, and that also means that we need quote to fall when his jump is done. And then we also need to make sure that quote does not fall through our floor. And we're just going to arbitrarily make our floor the middle of the screen, and we're just going to do a quick check of the Y value. Like if Y is greater than 240, then it means we've gone past the center of the screen and we've collided with our floor. So that's going to be a quick hack just to get us through until we have actual collision detection. And some of the details that I went over in the when I was showing you guys the actual game. Quick key press is a short jump and a long key press is a high jump. So when jump is pressed, there's no acceleration upwards, or you could think of it as being like instantaneous acceleration to the initial velocity up. And that's because we don't want him to slowly work into a jump. We just want him to jump right away, like instantaneously. And the other thing, when jump is held, there's no acceleration upwards, but gravity has no effect, or a very reduced effect. I can't really decide yet, so I'll play around with it, or you guys can play around with it, but we can look into that later. So the corollary to this is when jump expires or the button is released, gravity is in effect. And so you can almost think of it like as an anti-gravity jump. Like you get an initial velocity, and then while you're holding the button, you're in anti-gravity mode, but you only have so much time in that anti-gravity mode. But once you're falling, then you can't jump again, or you can't go into anti-gravity or anything like that. Another thing, I think I showed this in the when I was looking at Cave Story, but if you press release and then press again before your jump has expired and before you're falling, gravity will not have an effect, so you will get that anti-gravity effect that the jump has. And this is a little bit different from Mario. So for the implementation, we're going to introduce a nested class jump, and this is just to hide the jump details from the player class and give us a little bit of an interface so that we don't accidentally change variables later on that really should only be changed by the jumping logic. And so it's going to keep track of whether or not the jump is active and the total amount of time remaining in our jump. And like I said, it's sort of like a limited time anti-gravity effect that you get while you're going upwards. And this total amount of time remaining is how much anti-gravity effect you have left. And so what do we need to know? Positive y is down, and negative y is up, and this is because the top left corner of an image is 0, 0, and that's how STL surfaces work. So that's how a lot of 2D games are function. So I mean, you can like go to some effort to change this to be more intuitive, but we're just going to go with it because that's how a lot of games go. We need to know, are we on the ground? And to know this, we're going to have to store a little bit more state in our player for now. And it's going to be true if we collide with the floor, which for now is going to be our if y is greater than 240 check. And that's just a hack for now. We'll put a to do, temporary, remove me kind of thing, just so we know that we're going to replace it later. And then it's going to be false otherwise. And we also need to know if our jump has expired, and this is true if the velocity y is greater than or equal to 0, or we're falling, or the time remaining is less than 0. And yeah, that's all we need to know before we get started, so let's jump into it. So I think where we will start is in the game class when we're handling input right below where we check if left or right are pushed. We're going to start our player jump logic. So player jump. And this we'll call player horizontal movement. Our player jump will be the Z key. If input dot was key pressed SDL K Z, then we'll do something. Otherwise, if was key released, then we'll do something else. And that's something that we're going to do if the key was pressed is we're going to say player start jump. And if it was released, we'll say player stop jump. So this is just these two methods are not implemented yet, so let's go implement them now. In player.h, we'll add right below our stop moving void start jump and void stop jump. And let's put these in our CC file too. Right below stop moving. Do some magic. Word player. And yeah, let's make sure this compiles. It does. So let's look at the start jumping method in our player class. Start jump. So for our start jump, basically it's going to boil down to if we are on the ground, then we want to reset our jump and give ourselves an initial velocity. Otherwise, we're not on the ground. So if we're falling down, then we don't want to do anything. Otherwise, we're going up, so otherwise we are mid-jump, and we want to reactivate our anti-gravity stuff. So reactivate jump. And then for our stop jump, that just means we let go of the key, and all that's going to happen here is that we are just going to deactivate our jump, so to speak. So let's kind of just translate our pseudocode into real code. So if we'll just call a method on ground, otherwise we can get rid of this if we are falling down case because we don't do anything. So otherwise if we are mid-jump, and how do we know if we're mid-jump? And I'm going to say we're mid-jump if we are going up. which means our velocity y would be less than 0, which also means that we need a velocity y. But we'll get there in a second. So if we're on the ground, reset our jump, and give ourselves an initial velocity up. Otherwise, we are mid-jump, so we need to reactivate our jump. And we'll let the jump worry about if we have any time remaining in our stuff, because the player doesn't need to know that. So for resetting our jump, we'll just make a jump. For our struct, we'll have a struct jump, like so. And we're going to have a private member data called jump. So for our jump, we're just going to call jump.reset. And then for initial velocity up, we'll just say velocity y, which we still need to create, get some negative k jump speed, which we also need to create. So let's start with the k jump speed. This I have figured out from experimentation to be about 0.325f. Yeah, this is the same as the max speed x. I don't know if it's right yet, but we're not going to worry about it until we have some tiles to do some measurements and timing with. So this is in pixels per millisecond. Now we need a velocity y. So we'll go into player class, add in right next to velocity x, velocity y, and let's initialize this. So go up to our player constructor, and right below velocity x, add a velocity y. Okay, so otherwise, if velocity y is less than 0, we need to reactivate our jump, and this is just going to be jump.reactivate. So we can get rid of, since this is pretty obvious what this is doing, we can get rid of this pseudocode, reset our jumps. I'll leave that in there. If we are on the ground, we have an on-ground method that we need to create. So we'll call this bool. It'll be private because we don't need to know if we're on ground outside of our player class. So on ground is just going to return for now. I don't know if I reserve the right to change this. It's going to return a private member data on ground. And this we should also initialize. On ground, we'll initialize it to false. And then for stop jump, deactivate our jump is just going to be jump.deactivate. Alright, so now that we kind of know what we want our jump to be able to do, we should go ahead and define it. And we'll put it right below our struct sprite state. So struct jump. And this is going to have some private data in it. So it's like a full-fledged class. Let's just put in these methods, stub them out. We'll have a void reset, void reactivate, and a void deactivate. Alright. Before we actually implement those, let's see what else we need our jump for, and let's look at the update method later. I'm going to compile, make sure that this compiles now, fix any errors, undeclared use of, so we need to go into our player.h, and remember how I said we were going to have a private member variable called jump? Let's make that jump. Make. So yeah, we're just getting some undefined references. Let's, I might define these in the header file, so I'm not going to define them yet. Let's look at the jump structs some more. Okay, so I said we're going to need to know the remaining time or the time remaining, because that's easier and more fun to say than remaining time. And that's in milliseconds. And then we're also going to need to know whether it's active. So for this, I need to make a constructor so that these values get initialized to good values. So we'll initialize time remaining in milliseconds to 0 and active to false. Okay, so for reactivate, let's look at our slide really quickly. Split slides, do 9. We're only going to be able to reactivate if our time remaining is greater than 0. So what we can say, kind of trivially, is if time remaining is greater than 0, no, we don't want to return that. This is the void method. We set active to be equal to time remaining greater than 0. So this will only set active to be true if time remaining is greater than 0. Otherwise, active is going to be set to false. And for deactivate, again, this is going to be really easy. We're just going to set active to be equal to false. And then for reset, I'm going to put this in the actual CC file. Yeah, down below, player get sprite state. We'll call it player jump update. Nope, that's not what I meant to say. I meant to say reset. And for reset, what we're going to do is set time remaining in milliseconds to be equal to k jump time, which we need to define. And then we also need to reactivate our jump. Or we could think of it as activating it, but since reactivate is doing what we want it to do, we're just going to call reactivate. So let's define k jump time. We need to get rid of the slides and our header file. K jump time is going to be an integer. And again, by experimentation and imperfect experimentation at that, I've come up with 275 as the number of milliseconds to have a jump for, and I reserve the right to change that. Now let's see if it compiles for... Yes, it does. I'm going to make run just to see if we're still in here. Hey, we are. And everything looks okay. I can't jump yet because we're not actually updating his Y position ever. So let me jump into player CC. So this time remaining in milliseconds thing, this is never getting updated. It's never getting changed. So we're going to add an update method to our jump class. And this is going to be a void update, and it's going to take in an integer for time remaining, or elapsed time in milliseconds. And this is just so we can decrement our time remaining, and then set whether or not it's active if the time remaining is expired. So it's going to do two things. Yeah. So we'll go into we'll create this so that you know what it's going to do. Player jump update. And time remaining in milliseconds is going to be decremented by elapsed time in milliseconds. And this is going to only happen if we are actually active, because we don't want to take away time from the active time bank. We don't want to decrement the active the time remaining if we are not active. So if active, then we want to decrement. And then if we've decremented, we also want to say if active now is equal to, if time remaining is less than 0 or equal to 0, then we want to set active to be false. And we don't want to change active if time remaining is greater than 0. So that's our jump update. Let's call it inside of player update. So we can just do this at the beginning. It doesn't really matter. I mean, it matters, but no, it really doesn't. I'm going to compile. We still compile. Okay, now we need to actually update our y value. And our y value, we can just do our y value to be y plus equals velocity y times elapsed time in milliseconds. And let's round this like we did for our x. Okay, now y, or velocity y, is going to get updated differently depending on if the jump is active. So if jump.active, and do I have an active method? No. I want to create one. So bool active const, and this will just return active. So if our jump is active, then we're not going to do anything. Don't do anything. Otherwise, if our jump is not active, which I'm going to reduce in a second, if our jump is not active, then we want to say velocity y plus equals acceleration y, or k gravity, we'll create in a second, times elapsed time in milliseconds. But we want to make sure that we don't go over a certain threshold, so we'll do standard min of velocity y plus this, and we don't want to go over k max speed y. And we do min because, remember, velocity of y when you're falling is going to be greater than 0. And so this, since clearly we don't need this first case, we can just check for the not case. Okay, so now we're updating our y. I can show you what happens now. It's not going to be pretty though. But before I show you, let me of course define k-gravity, which I have determined to be about the same speed as the walking acceleration. Not the same speed, but the same as the walking acceleration. And this is totally just an estimate. We'll fix it later. And then we also need k max speed y, and I'm going to leave that to be the same as the jump speed. Alright, so I can show you really quickly what it's going to look like. It's not going to be pretty though. So make run, and he just falls. So let's implement our hacky collision detection. So for our hacky to do, remove this hack and surround it. If y is greater than, and I'm going to say 320, it's a little bit more than half, but that's so we can get a nice fall before we actually hit the ground. And it's just for fun, you know? So if it goes above 320, we just want to reset it to be 320. We're also going to update the velocity too, so if it's greater than or equal to 320, we'll just set velocity y to be equal to 0.0f. And then we want to update our on-ground member variable, and that's going to be equal to y is equal to 320. So this means we've hit the ground. So I will compile. And it compiles. So let's try it out. Make run. So he falls and he hits the ground. This is good. We still get walking left and right. And he stops inside, so let's try jumping. Ooh, short jump. Ooh, long jump. Short jump, long jump. Short jump, long jump. So let's jump around a little bit. Okay, so here's the thing though. When I'm moving to the right, and I jump and I let go of right, I stop midair. And this is not how it's supposed to be. It's supposed to be more like how I look now. But if I let go, I get that stopping as if I was actually walking. So I need to remove that x velocity x slowdown. So I'll go ahead and look at player CC, and this is a really easy fix. All we do is say, as long as we're on the ground, apply this slowdown to our velocity x. So let's compile and try it out again. Falls. Okay, so I'm going to do that whole let go of the right arrow key midair and see how it goes. And it goes well! Perfect! Sweet! Yay! Okay, this has been a lot of fun. This was probably one of our most complicated episodes so far, but I think it's worth it, Games are just so fun, and Cave Story in particular is just so fun, and just making games is fun. So, pretty soon, what are we going to do next? Next, we're going to make a map for Quote to move around in, and for him to jump on things. So that means collision detection, and having a background image that we can more sprites on the screen, and then once we have more sprites on the screen, then we can get enemies and maybe bosses after that. But we need guns before we deal with bosses or enemies. So yeah, good stuff coming up, guys. Good stuff. Thanks for watching.